Good morning, students. So, day 28, we are starting today. Yesterday, we stopped at prism, so we are starting from prism only. Okay. So, prism, what is prism here? Two refractive surfaces, but not curved. Okay, plane surfaces. Is my voice clear to you? Okay. Prism is two refractive surfaces which are plane. Right. This here is first refractive surface. This is second refractive surface. And this angle is called angle of prism. Okay. Then from here, this is incident ray. Take normal here, normal to this first surface. Then refraction is happening. The refraction is like this. This is how the refracted ray is going. Again, one more normal here, normal to this surface this time. Okay. Right. So this is normal to this surface. Then the ray will be going out. It's like this. This is angle of incidence. This is angle of refraction. This is again angle of incidence. And this is angle of emergence. Coefficient of refractive index we can say is mu. So we apply Snell's law over here on the first surface. What we are getting? 1 sin E equal to mu sin R1. 1 sin I equal to mu sin R1. Then you apply on second surface. When you apply on second surface, you are getting mu sin R2 equal to 1 sin E. Snell's law on the two surfaces. Okay, then what else we have? The conclusion of this one we get is angle of prism is actually equal to R1 plus R2. Okay, and delta. Now what is delta here? This is incident ray. Okay, and this one is emergent ray. The angle between them is called delta. How much deviation this prism is producing, that's called delta. And this delta value is I plus E minus A. I plus E minus A. This we have to remember. This is generally for a prism we should be knowing. First, applying Snell's law at two surfaces, then angle of prism should be equal to R1 plus R2. R1 plus R1 and R2 are these. Okay, and delta is equal to I plus E minus E. Okay. Then what is important for us in the prism? Two things are there which are there in our syllabus. So both you'll see. One is minimum deviation. Minimum deviation. So for minimum deviation, first thing we should know is there is a graph. We need to talk about a graph first. Okay. So how is the graph? Graph is between delta and angle of incidence. Delta and angle of incidence. So when angle of incidence is small, okay, go back and check. If I is small, that means if suppose I is 0. I is 0. So R1 also will be 0. Correct or not? So delta will be what? E minus A. In that case, E will be very high. Okay. So E will be high and E minus A will be delta. So delta value also will be high. When I is almost 0, delta value is very high. Okay. But as I you are increasing, when I increases, delta decreases. So it decreases. How we are getting it? From measurement. In the lab, we are measuring it. And from the lab only this graph has come. Okay. So it's something like this. Like this it will come and like this. Graph is not symmetric. Remember. Okay. So here is delta minimum. This is delta minimum. And this delta minimum is obtained when I value is equal to E value. That means angle of incidence is equal to angle of emergence. Remember that. So if angle of incidence is equal to angle of emergence, in any case, it will be equal to, or it will give us R1 equal to R2. You can see from it. If E and I, this is E and this is here I, right? I have written here also E. Okay, so this is I. So if E and I are equal, then R1 and R2 will also be equal. Because if this and this are equal, we will say mu sin R1 equal to mu sin R2, mu gets cancelled. That is R1 equal to R2. Okay. So I equal to E is fine. Second condition that we are getting is R1 is also equal to R2. So that means A, which is equal to R1 plus R2, will become 2R1. So R1 equal to A by 2. Okay, and second thing, delta. Now we are saying delta is equal to I plus E minus A, but I and E are equal. So we'll write 2I minus A. So I will be what? A plus delta by 2. Okay, A value is this and I value is this. A plus delta by 2. Okay, not only delta, it's not under delta alone, it is actually under both. Then, so mu will be writing what? Mu is equal to what? Sin I by sin R1. What are we getting? We are getting this as sin of A plus delta by 2 by sin A by 2. Now, these are all conditions in which we are getting minimum deviation. Okay, these are the formulas. And what is the main condition here? I equal to E. This. Okay, we need to remember that. Then, what is the second thing in prism important for us? That is thin prism. Thin prism. Now, thin prism means what? When angle of prism A will be less or equal to 6 degrees. We call it as thin prism. Okay, angle is less than 6 degrees or equal to 6 degrees, we will be calling as thin prism. So, when A angle is very small, so that means R1, R2 will be very small. R1 and R2, because A equal to R1 plus R2. A itself is very small, so R1 and R2 also will be smaller. So that means I and E also will be smaller then, because all are corresponding to each other. Here they are. If this is small, this also will be smaller. So if this is for all the small angles, all angles here are small. Here are smaller. So what we will do? We are not going to use sign at all. Without sign, we will be doing all. So Snell's law, when we are writing for first surface was what? 1 sin I equal to mu sin R1. So sign we will remove. We will write I equal to mu R1. Same way we are going to write for E. We will write it what? Mu R2 equal to E. Then A will be what? What will be A? A will be R1 plus R2 only. There is no change. Delta is 2I minus A, we know. 2I minus A. Okay. Or I plus E minus A. Don't write 2I minus A. I plus E minus A. Because in this one we didn't say that I and E are equal. Okay. So I is mu R1 plus mu R2 minus R1 plus R2. So what are we getting here? We take R1 on one side, so R1 mu minus 1 plus R2 into mu minus 1. Mu minus 1 is common now. Mu minus 1 into R1 plus R2. R1 plus R2 is what? A. So this is mu minus 1 into A. Okay, the deviation in the case of thin prism is mu minus 1 into A. And condition for minimum deviation, mu equal to sine of A plus delta by 2 by sine A by 2. Okay, so these are the two cases in prism we have and we should remember. Thin prism I have written over here, but we have done it already. Okay, then Then let's move ahead. There is a question here. In a prism A equal to 60 degrees, mu equal to root 3, find delta minimum. Now he is talking about delta minimum directly. Okay, so what to do? A equal to 60 degrees. Okay, for delta minimum, we know that R1 and R2 are equal. So A will be equal to 2R. So R is 30 degrees. We got R equal to 30 degrees. What is given then? Mu equal to root 3 given. Okay, and delta minimum is asking. That means first we have to get I value, right? So what you can do? 1 sine I equal to mu sine R, right? Sine I equal to, this is root 3 and this is sine 60, no, sine 30. So sine 30 means 1 by 2. So that means I is 60 degrees. I value is 60 degrees. Now delta value is what? 2I minus A. So 2 into 60, 2 into 60 minus 60. Answer is 60. Very simple. Okay. So delta value is also coming 60 degrees over here. Right? We could have used direct formula also, mu equal to sine of A plus delta by 2 by sine A by 2. That also we could have done. That also we could have done. Okay. Move ahead. In a prism, A equal to 4 degrees. Now when you say A equal to 4 degrees, it means this belongs to thin prism. Mu equal to 1.5 and delta minimum is asking. Okay. So in thin prism, delta equal to what? Delta equal to mu minus 1 into A. Mu is 1.5, 1.5 minus 1, that is 0.5, 0.5 into 4 degrees, that means 2 degrees. That's delta minimum. Okay, simple? Okay, go ahead. Find I for which refracted ray is parallel to base of prism. Okay, so if this is how the prism is, then he says that A is 60 degrees here, mu is root 3. Okay, then what is he asking? I value. Alright, so what's happening here? This is how the incident ray is going. Refracted ray is parallel to base, and this is how emergent ray will be there. Okay, now what we can say here in this case, this A value is given and mu is given root 3. Okay, so is it like this particular case we have, this is equilateral prism? Okay, why? Because we require little more information on that. This is normal here. Okay, and this is normal here. Okay, it's like this. So I value he is asking us. Mu is given, A is given. Okay, this is R1 and this is R2. Correct. Now because of this and this, can we get anything? Because he didn't give minimum deviations case, or what case? Nothing is. So what more is required? Maybe it's equilateral prism. If this is 60 and this is also 60, then we can solve it. What you can do then? If this is 60 and he says this is parallel to this base, so then this is also 60. And if this is 60, that means R1 will be 30. So if R1 is 30, then that's all, our work is over. We will apply Snell's law here. 1 sine I equal to mu sine R1. Okay, sine I equal to, this is root 3 and R1 is 30 degrees. So sine 30. So I value is coming 60. Okay, so here what was required? Find I for which refracted ray is parallel to base of equilateral prism. Equilateral prism. Okay. Here we can do this. Then what next is there? Let's see. Next one, find mu if light retraces its path. Now here this is silvered. We have made it a mirror. So when light retraces its path, remember only it retraces from mirror first, and it retraces only when the light is going to hit mirror perpendicularly. In the case of plane mirror, and in the case of curved mirrors, then also if it hits perpendicularly, it passes through center of curvature. Okay. So this is also going to retrace its path. So when it's retracing its path, it means definitely it will be going in this way. Goes and comes back. Okay, and this is what? This is along the normal. Okay, retracement is possible, or retraces, this condition is possible when light hits mirror perpendicularly. Light retraces its path only when it hits mirror perpendicularly. It hits mirror normally. So if it is hitting mirror normally, that means here angle of incidence, that is R2 value is 0. So we'll write it over here, R2 is 0. So that means A equal to R1, yes. A equal to R1, that is 45. Okay, what he wants? Mu he wants. That's all. Over question. So I value we know, R1 value we know, this is 45. So 1 sine 60 to mu sine 45. Root 3 by 2 mu to 1 by root 2. So mu value is coming root over 3 by 2. Okay. So like this we will be doing. But these all you have to remember, then only you can solve these questions. Like this. Like this is there means here this value is 0. 45, 0, right? This is how you should be doing it. Clear? Okay. Then what else we can do? Next is dispersion. Dispersion is what then? Splitting of white light into its constituent colors. Splitting of white light into its constituent colors. Constituents colors. Okay, and prism does it. How prism does this? How prism is able to do it? Because we know that mu is actually inversely proportional to lambda. Not exactly lambda, but we will take this relation. Okay, mu is inversely proportional to lambda. So for every color, coefficient of refractive index of the prism is different. Okay, and when we are going to talk about dispersion, we are going to talk about thin prism. Okay, we are going to talk about thin prism. Now, thin prism says as delta equal to mu minus 1 into A. So, if mu for every color is different, that means deviation for every color will be different. So, since deviation is for every color is different, what we can see through prism is, we can see all the colors splits from the white color. Okay, so how it is going to happen? We consider this is our thin prism only. It's like this. Okay, and suppose from the center I take like this, just like lens I am trying to do. Okay, deviation I will show through the middle only. I am not going to show through how it is to the first surface, how it is going to be second surface. Directly I will be showing you the deviation from the center. Exactly like our thin lens. So this is thin prism, so it's identical to thin prism, thin lens. Okay, we'll do it. Okay, we'll do with pen only, white. Okay, so it's like this. This goes. Then what happens? Now, splitting of colors is going to happen. So I'm going to show you red and violet only. This is violet like this. Okay, and then it will be red. In between will be all other colors. Okay, all other colors will be in between. So question now here is, coefficient of refractive index is more for whom? We know that lambda r is maximum and lambda violet is minimum. So from here, if lambda r is maximum and lambda violet is minimum, we can say that mu v is more than mu r, because mu is inversely proportional to lambda. So from here we can get that delta v will be more than delta r. In fact, delta v will be maximum. So you can see that yes, that is correct also. We have made it in that way only. So if we can show here the deviation, okay, we can show here the deviation. This is the incident ray. Okay, this is our incident ray here, and let's see the angle. So we will say that this is delta V and this is delta R. This is delta V and this is delta R. Okay, and the difference between the two we call as angle of dispersion. Okay, angle of dispersion. Angle of dispersion we measure as or represent as theta. It is actually delta V minus delta R. It is delta V minus delta R. Okay, this is angle of dispersion. Then another thing is there in the prism, that is called dispersion power, dispersing power. Okay, dispersing power. That means how much a prism can disperse, and this we represent with omega. Now what is this omega? Omega is the ratio of angle of dispersion to mean deviation. Mean deviation means deviation produced in yellow color. So dispersing power is omega equal to theta by delta y. Theta is, here is delta v minus delta r. Okay, so delta v we can write here like mu v minus 1 into a, and delta r we can write as mu r minus 1 into a. Let's see what is its value. We'll get its value first. Okay, theta value I am doing it here. Theta is delta v minus delta r, that is mu v minus 1 into a minus mu r minus 1 into a. Okay, so what we are getting? We will be getting mu v into a minus mu r into a minus a and plus a. So a gets cancelled. Here what we are getting? Mu v minus mu r into a. That is theta value. So you'll place it over there. Mu v minus mu r into a. And what is delta y? Mu y minus 1 into a. So a gets cancelled. So we are getting dispersive power as mu v minus mu r by mu y minus 1. Okay, mu v minus mu r by mu y minus 1. Okay. Alright. Then let's see what type of questions are there on this one. So is there two prisms are there, prism A and prism B. Delta for blue color is 12, delta for red color is 10. Delta for blue color here is 10 degrees and delta for red color is 8. Which prism has more dispersive power? Okay. So omega for A will be delta B minus delta R by delta Y. Same way here also. Omega for B, delta B minus delta R by delta Y. So delta B minus delta R is what? 2 degrees. And here also delta B minus delta R is again 2 degrees. What is delta Y here and what is delta Y here? How to calculate? The delta Y is mean deviation. Okay, so mean deviation how to find? Mean deviation will be delta B plus delta R by 2. So 12 plus 10 by 2, that is 11. 22 by 2, 11. So this is 11 degrees. There it will be 10 plus 8 by 2. 10 plus 8 by 2 means 9. So which prism has more dispersive power? Let's say B. B's dispersive power is more than dispersive power of A. Okay. Alright. Now combination of prism. Why combination of prism is required? So that, okay, first thing is what's happening in the prism. Two things are happening. Dispersion is also happening, deviation is also happening. In fact, dispersion we are measuring in terms of deviation only, delta V minus delta R. That is only the angle of dispersion. Okay. So two things are happening, deviation and dispersion. So when we have the combination, we want to have any one. Either deviation should be there or dispersion should be there. Okay. So we produce that kind of combination that will either produce deviation without dispersion, or second case we have dispersion without deviation. Dispersion without deviation. Okay. First case we have in which we are talking about no dispersion. Second case we are talking about no deviation. Now dispersion means we have, first of all we have a combination of prisms. So combination of prisms, how we are going to make? Okay, we'll try. Combination of prism we'll make here. Okay, something like this, and we'll join it here. So like this, there are two prisms. Okay, it's better. I think I should make it with the proper square. Okay, then it will be better. So if you make it with a square, okay, this way also possible. Okay, what type of prisms we'll use? One is made from crown glass, other one is made from flint glass. This is flint glass. But in this one, what is the problem? When I have made it in the square, this surface and this surface has become parallel. Right or not? Both are parallel. Actually, if I made it freehand, I think that only will be better. If I make it with a freehand. Yes. Okay. So here it is. So one prism. Okay. And this is the another prism. It's like this. Okay. Now first prism's angle of prism we'll say is A, and other one's is A dash. Like this it is. Now what you want? Deviation you want, but dispersion you don't want. So this is also going to produce dispersion. Yes. This will also produce dispersion. Yes. So you don't want dispersion means theta 1 plus theta 2 equal to 0. That means theta 1 equal to minus theta. What is theta 1? Say mu v 1 minus mu r 1 into a1. Here mu v2 minus mu r2 into a dash. So sometime question will be there, then they will give you mu v1, mu r1, mu v2, mu r2 and a1. And they will ask you that for the combination, what will be the angle of prism? So you say, okay, a dash is there and a dash will be equal to this by this. So this is the condition. First question can be asked from this. Next question will be, what is the net deviation? Dispersion is 0. What is the net deviation? The net deviation will be, again will be produced by both delta 1 plus delta 2. Okay, so what is delta 1? Delta 1 will be written as mu y minus 1 into a1. Mu y1 minus 1 into a1 plus mu y2 minus 1 into a or a dash. Okay. A and A dash, not A. So A dash value from where we'll be getting? From here, get A dash, we'll be putting into this one. That is it. You don't have to remember any formula here. Just take the A dash value from here and put it. And then get the answer. That will be delta net. Same thing we are going to do there. Dispersion without deviation. Okay. So here you want dispersion, you don't want deviation. That means here delta 1 plus delta 2 should be 0. So what is this? Mu y minus 1 into A, and this one will take that side. So minus mu y dash minus 1 into A dash. Okay. Mu y minus 1 into A, mu dash y minus 1 into A dash. Clear? Then what you want? Dispersion. Now dispersion will be what? Theta 1 plus theta 2. So here mu v minus mu r into A plus mu dash v minus mu dash r into A dash. A dash value will be putting from here. Okay, here also we'll put it in terms of dash only. So 1 and all that you remove. Okay, let it be. Fine. Okay. So here we have taken in terms of dash. Okay, here we have taken in terms of 1 and 2. Right. So these are the two cases that we have in combination of prism. So you don't have to remember formula, only remember this. Theta 1 plus theta 2 equal to 0 here, and net deviation delta 1 plus delta 2 here, delta 1 plus delta 2 0, and net dispersion is theta 1 plus theta 2. Okay, this is what we know about prism. Right. So prism is over. Now optical instruments. Optical instruments why we use? If we want to see something which is very far away, which is not visible with our eyes, we take help of microscope, rather telescope. And if there is very tiny things in front of us that we cannot see properly, we use microscope for that. Okay, so they are going to aid us in viewing and analyzing. Okay, we use these optical instruments. The simple microscope is what? Simple microscope is actually a convex lens, a powerful convex lens. Okay, which can produce magnification up to 9 times. Okay, produces 9 times magnification. Okay, so if it's a convex lens, then how it's going to add us as far as viewing is concerned? So if this is a convex lens like this, okay, and convex lens makes what type of images? We say real also it makes and virtual also it makes. Okay, but here this has to be seen by eye. You have to put this lens in front of the eye. Okay, so this convex lens has to make the image on the same side as that of the object. That means we are talking about a virtual image. It has to make virtual image on. Okay, so suppose it makes the virtual image at least distance of distinct vision. What is that least distance of distinct vision? We call it as capital D, and its value is 25 centimeters. So if suppose that we kept object over here, here's the object. Okay, the ray is going in this way here, and this one is passing like this. So we are going to retrace them like this and like this, and here is the image of this object is there, and this is forming a D, capital D. What is D? D is 25 centimeter. Remember that. We call it as least distance of distinct vision. Least distance of distinct vision. Correct? Fine. Now we have to find its magnification. Okay, magnification we want. So magnification, what we have said, V by U only, no? Magnification of lens, V by U. Correct? No doubt about that. So where we want this V? V is at D. V is at D. when you want that the image to be formed at D. Okay, so first case I am writing, we want this V to be at D. But what is this U then? For U, I am going to use the formula 1 by V minus 1 by U equal to 1 by F. Okay, then 1 by U we want. And what is 1 V came? V we have taken as D. So first of all, let's change that one that side. So it's 1 by V minus 1 by F equal to 1 by U. Correct? I want 1 by U value. So now question is, what is V? V is actually, because light is going from this side and this is also on the left, so D is negative. So minus 1 by V minus 1 by F equal to 1 by U. Okay, so what we are getting? Minus you take outside, F plus D by dF. Let's put it over there. So D into F plus D by dF. F plus D by dF. That's all. So this is only our, so it is coming 1 plus D by F. This is only the magnification. When you are making the image at D, least distance of distinct vision, 1 plus D by F. But if suppose that we want to make the image at infinity, infinity means is when the eye will be relaxed. When you are making the image at D, eye will be in stress. At infinity only, eye will be relaxed. Okay, so if suppose that final image I want to make at infinity, then what will be the answer? Very simple it is. In that case, you will be focus. You will be at focus. Then only the image will be formed at infinity. So here it will become 1 plus D by F. This will not be there. Okay. So this term, when you are saying magnification 2, magnification 2 is going to come as D by F when image is at infinity. Image is at infinity. Okay, image is going to be at infinity. Then in that case, our magnification becomes D by F. Clear? So how to remember this? This, as we know that magnification is V by U, we calculated it is 1 plus D by F. This is when the image is forming at D. And second one, when the image is forming at infinity. At that time, your magnification is D by F. Okay, this is the simplest way I am saying. Otherwise, the method is what? Angular magnification, beta by alpha. I am not going into beta by alpha, I am just in a simple way I am telling you. Okay. So 1 plus D by F, we got this one. So when it is at infinity, we are getting the magnification as D by F alone. So what is the difference? How much is the magnification difference when the image is forming at infinity and image is forming at D? Difference of 1. Okay. Difference of 1 is there in both the cases. Clear? Okay. Now you have compound microscope. Compound microscope, when we want magnification even more than 9. 9 times we already got the simple microscope. We want more. So then what we require? We will be adding one more lens into it. Okay. We'll put one more lens. Okay. So here is lens number 1. And let's assume that this is the axis on which we are going to get the other lens also. And this is the other lens. Okay. Now this is called objective. And this is called eye lens or eyepiece. Okay. Now in this one, you will have small object over here. We will take the rays in this way. Okay, and this will be going from here. You take it slightly more. Okay. Like this. Like this. Okay. So here is the image formation. Then suppose we continue with them. Then what will happen? We go like this. Go like this. Then you can retrace them back. Okay, here somewhere will be a final image for the eye. Here is eye. Okay, so this is the object for the eye, and it's going to make its image on the retina. Okay, what this is now? This is object distance from objective. This is image distance from objective. Which one? This one. And this is image made by eyepiece, and this is object for eyepiece. Just like this. But these are two lenses. So we know that whenever we talk about magnification of two lenses we write as M1 into M2. This is what we have learned. So M1 is what? V naught by U naught. It's a real image, V naught by U naught. Okay, in the previous case, this one was virtual image. So here should be minus. So minus should be cancelled, right? Yeah, this is cancelled from here. Fine, after that is okay. Fine, no problem, okay. Okay, fine. So this is real image, so V naught by U naught into M2. M2 is what? Eye lens. And its magnification we already have calculated. Which one? Simple microscope. So 1 plus D by F. 1 plus D by F. When image is at D. Image is at D. Okay. And V naught by U naught into D by F. When image is at infinity. Very simple. So if you know simple microscope, what is its magnification? That means you have knowledge about compound microscope also. Now in compound microscope, sometimes they ask you what is the length of microscope. It is V naught plus UV. Length of microscope is V naught plus UV. Remember. Okay, fine. Let's solve problems on this compound microscope now. Optical instruments also an important topic. Okay, one question at least you can expect, and sometimes two questions also from this small topic itself. Okay, so see now what it is. Focal length of objective given, focal length of eyepiece given, magnification for relaxed eye. Relaxed eye means final image is forming at infinity, and then he is asking length of the tube. Okay, see then what we have to do. Okay, so magnification for relaxed eye is 45. So magnification is what? We say V naught by U naught. D by F. Okay, so this is 45 given. We have no idea about V naught, we have no idea about U naught. D we know is 25 and Fe is given 5. Right, so this is 5 5 ja, this is 5 9 ja. So V naught by U naught equal to 9 we know. This information we have. Okay, then length of the tube he is asking. Length of the tube is what? V naught plus U. Okay, and here V naught by U naught we have. That means V naught equal to 9 U naught. Now what we can do? FO is given. If FO is given, from there I can get V naught value. Surely. Okay, so we'll do that. So 1 by FO equal to 1 by V naught minus 1 by U naught. What is FO? 1. So this is 1. V naught is equal to 9 U naught. So 9 U naught minus U naught. Real image, no, this one. Okay. So this one is adding here. So this is 9 U naught. This is 1. This is 9. And this is 1. So 9 U naught equal to 10. So U naught equal to 10 by 9. So if U naught I know, That means V is also, V naught also I know, right? So V naught is what? V naught equal to 9 times 10 by 9. So V naught is 10 centimeters. Okay. Now how to get UE? Now it's given to us that relaxed eye is there. That means image is forming at infinity. When image forms at infinity by the eyepiece lens, when object will be at focus. So that means UE is actually equal to FE. Okay. UE is actually equal to FE. So what is length of microscope? V naught, which is 10, and FE, which is 5. So length of microscope is 15 centimeters. That is it. Over. So length of microscope is 15 centimeters. Let's move ahead. See now. Now you will understand this one in a better way because similar question this is. Now in this one L is given. Again relaxed eye. FE is given, but this time he is asking UO. Okay. Okay. So L is what? L V naught plus UE, but now I am writing V naught plus FE on because relaxed eye is given. Okay, this is 14. V naught I don't know, but FE I know 5. So V naught value 9. V naught value is given 9. Now what question is asking you? Question is asking us UO. Okay, can we do it now? For getting UO, I require FO also. Okay, fine. So what to do? For that only relax size magnification is given to us. What is magnification? Magnification is V naught by U naught into D by FE. Okay. Okay, fine. So M value is 25. V naught value I calculated already 9. U naught value we have to find. D is 25 and F is given 5. F is given 5. So this is 5 and this is also 5. So U naught value is coming 9 by 5 centimeters. That's all. Now from here we could have also obtained, if suppose that you would have said that find FO. So FO also we can calculate because now U naught also you have and V naught also you have. So we can calculate FO also. Okay, but this all you should remember, then only we can do it. Okay. Let's see more. FO is given 1.2, FE is given 3, UO is given 1.25, and again it is for relaxed eye. Relaxed eye. Find magnification, he says. Okay. What's the formula? Magnification is V naught by U naught into D by FE. Okay. What is he asking? M. And what is given? FO is given, FE is given, U naught is given. Okay. V naught is not given. Okay, so first we'll find V naught. U naught and FO is given anyhow. So 1 by FO equal to 1 by VO minus 1 by U. This is 1 by 1.2. This will bring here plus 1 by minus 1.25. We are using sign convention. Okay. Equal to 1 by V naught. So 1.2 and 1.25 are here. Okay. LCM will say 1.2 into 1.25. This is 1.25 minus plus 1.2 equal to 1 by V naught. So V naught is equal to 1.25 into 1.2 by 0.05. Okay. No, this I have done it wrong. This is plus and this is minus. Yeah, now it's okay. Because V naught cannot be negative. It's a real image. Okay, it's a real image. So this is 1 by 1.2 minus 1 by 1.25. So it will become positive one. So this is V naught value. Okay, let's put it over here. I think everything we have done. So 1.2 into 1.25 by 0.05 into U naught, which is 1.25 again, D value 25 and Fe value 3. So 1.25, 1.25 cancel. 1.2 into 100 by 5 into 25 by 3. So this is 5 and this is 0.4. So what's coming? Magnification is coming 200. So 200 times you are able to increase the size of object for viewing. Okay, 200 times magnification. Okay, next question. Next question says maximum magnification that can be obtained with convex lens of focal length 2.5 centimeters. So that means he is talking about simple microscope. How much is the maximum magnification we can produce? Now we know that maximum magnification has to be when the object, rather image, is obtained at D. Okay, and what is that? It is 1 plus D by F. 1 plus D by F. And how much is that then? It's 1 plus 25 by 2.5. That means 11. Okay, maximum magnification you can have is 11. Right? Okay, one more you see. Objective lens produces magnification of 10. For total magnification of 100, in which image forms at D, find Fe. Okay, so first thing is magnification when the image is formed at D. Let's write it first. It is V naught by U naught 1 plus D by F. Okay, objective lens produces magnification of 10. That means this is 10. Okay, and what? This is 100. This is 1 plus 25 by F. And he is asking F only. That's it. No problem. This is 10. Then 10 minus 1 equal to 25 by F. So F equal to 25 by 9. Okay. 25 by 9 is coming as focal length of eyepiece. Alright, see one more. This is for simple microscope. M for simple microscope is 6. Then focal length is what? If image forms at D. Simple question again. Magnification when the image forms at D is 1 plus D by F. This is given 6. 1 plus 25 by F. So 5 equal to 25 by F. So F equal to 5. Now these are the types of questions that are asked. Okay, see, very simple it is. Now then, another instrument that we have, telescope. And which telescope we are going to talk? We are going to talk about astronomical telescope. Astronomical telescope. Again, two lenses are there. Okay. First one is bigger one. No. First is bigger one, bigger in size. Second one is smaller one. In microscope, it was the opposite. Okay. So this is eyepiece or eye lens. This is objective. Now, since the object is at infinity, the rays will be coming parallel to each other. So, how we are going to take rays in this one? One is passing through this like straight only because it's passing through the pole. Okay, and another one parallel to this. Okay, so we'll take parallel to this. Okay, here it is. Okay, parallelly incident. This will not be same obviously. Okay, this is not same. So now what will happen? It is going to be, this will be converged. So if it's getting converged, let's say it's getting converged over here. This is the image we are getting. Okay, from here then it will go to the eye. Eye is here at the back. So we can take it like this. Okay, this is eye here. Then for eye, from where the rays are coming, they are coming from, wait a second, what I have done is correct only. No, I have taken it directly. So this diagram, I have made it wrong. Let's correct it, okay. Okay, like this, and one we will take from, now we can take it. Earlier what I took straight line only. That's why. Okay. So now retrace this. This is line here and this line is here. So for eye, image is forming here. Like this is the ray diagram for this. Okay. Now what we have to do in this case? Okay, it's not like microscope. It's a different case altogether. So in this one, we take this as angle alpha. Here angular magnification only is the way. This is alpha. This is alpha. That means if straight lines are coming, if telescope is not there, what angle they will be making on the eye? Alpha. But why? Because this telescope we have. So now the same thing is making this angle, which is beta. Okay. So magnification will be saying is beta by alpha. Now what is beta? Beta value is this by this. So what this is actually? This is UE. And this is what? VO. And let's assume that this is AB. So alpha value is AB by VO and beta value is AB by UE. Okay. So AB by UE and here is AB by VO. So magnification actually is VO by UE. Magnification is VO by U. Okay. Fine. Now what more we can do? We can find what is UE. VO is fine. And what will be VO, you know? Because the rays are coming from infinity. So basically VO is FO. Okay. So this actually is FO. Now what is UE? That UE value will be finding. We'll get the formula. So this is eyepiece. So we can write this 1 by Fe equal to 1 by VE minus 1 by UE. Okay. Now what I want? UE value. Now VE value will be depending on where we want the final image, where we want D and we want at infinity. Okay. So suppose that first we want VE at infinity. So when you want V at infinity, 1 by V means 0. When image forms at infinity? When UE equal to Fe. Correct or no? When this is 0, then means UE equal to Fe. So in that case, our magnification formula will be FO by Fe. When? When you want final image at infinity. Second one, when we want VE at D. VE at D. Then this formula again we will use 1 by Fe equal to 1 by V. V value we want is D. This is D. No, not this. This. This is VE. Okay. This value you want as D. So negative or positive? Negative, because light is going in this direction and you are measuring in opposite direction. So put here minus D, minus 1 by UV. Bring it here. This is 1 by FE plus 1 by D. And UV is also where? UV is also on the left side. So you can take it as positive. Okay. By sign conventions. What we are getting? Directly shall I place it over here? So our magnification is going to be V naught, or rather F naught, into 1 by FE plus 1 by D. So when image is going to be formed at D, this is magnification, and when image is going to be formed at infinity, it is FO by F. Now this is slightly different than microscope. So yes, this also we have to remember. So remember the formula for compound microscope. Okay, simple microscope you will have anyhow. Okay, and remember it for telescope also. So see now what questions are there on telescope now. What's given? FO is given. Okay, FO is there, FE is there, and final image at infinity also and D also. We want to find magnification both the cases. So okay. So that means we will remember the formula, nothing else. Okay. So in case of image forms at infinity, it is FO by FE. So FO 2 centimeter and FE is 5 centimeter. So what kind of telescope this is? So small. Make it at 20. Okay. Make this as 20 at least. Okay. So this is 20. So at least magnification is 4. Okay. When the image is formed at D, then what is the magnification formula? Say FO, then 1 by FE plus 1 by D. Am I correct? Let's check. Yes. Okay. Then FO value is there 20. FE value is 5. And D is 1 by 25. Okay. So what we are getting? 20 here. This is 25. This is 5. This is plus 1. So 20 by 25 into 6. 4 by 5. There is 24 by 5. Okay. So when image is forming at D, magnification is 24 by 5 and here it is 4. Clear? What is the unit of magnification? No units. No units. Okay. Alright. Next is this. So FO value 180, FE value 6 for normal adjustment. Now normal adjustment means what? Normal adjustment means is relaxed eye. Relaxed eye means what? Image forming at infinity. So image forming at infinity means FO by FE. That's all. FO by FE 180 by 6, that is 30 times. Okay, magnification will be 30 times. This is not wrong. 30 times I have written. Okay, 30 cross. Sometimes you can see that this symbol will be used. Okay, so don't worry. This is actually 30 times here. In magnification, they use it. Okay. Okay, see then. Magnification for telescope is 9. Distance between lenses is 20. Focal length of both lenses is. This is objective question. Okay. What to do? M for telescope is given. Now which one it is, we don't know. Whether it is the image is forming at D or image is forming at infinity. We have no idea. Distance between lenses is 20 centimeters. That means length of telescope. Alright. Now both we have to check. So let's see first for infinity. For image at infinity. Magnification is 9. So it's FO by FE. So 9 equal to FO by FE. First. Okay. distance between the lenses, that means length. Length is what? FO plus UE. But we are taking that image is at infinity. That means UE will be equal to FE on. L is FO plus FE. L value given 20. From here I am getting FO is 9 FE. So 9 FE plus FE. That is 10 FE equal to 20. So FE is 2. If FE is 2, that means FO is 18. We have to check, is it there or not there? 18 and 2, it is there. And we have only one option correct, so definitely it is there because it is satisfying one of the case. Okay. Other case can we find? Because in other case, what will happen? Your M will become FO by 1 plus, no, what it is? M is equal to FO into 1 by FE plus 1 by D. Okay, let's check. Can we do that also? So magnification is given 9. Okay, FO is given? No. FE is given? No. FO 1 by FE plus 1 by 25. Okay, it will be slightly difficult in calculation. It will be difficult. So only this case we can apply on this one. Okay, this case is not possible. So what we are getting? FE is 2 and FO is 18. So this one. Okay. Then what? Magnification of telescope is 10. Length of telescope 44 and FO is what? Okay. So this is for which adjustment? Normal adjustment or final image is at capital D? Okay. So let's see. Both the cases we will check. Let's see which one is we are able to do. Okay. So magnification of telescope. First I am saying that V is at infinity. Okay. The final image is forming at infinity. Right. The final image is forming at infinity. That means magnification is FO by FE. So 10 equal to FO by FE first. Then length of telescope. Length of telescope is FO plus FE. Yes, we can find it very easily from here. This is 44. FO equal to 10 FE plus FE. That is 11 FE. So FE equal to 4 centimeters. That means FO equal to 40 centimeters. Okay. So when you are taking normal adjustment, you can find it very easily. Okay, we got it. But if you are not taking normal adjustment, it's going to give us problem. Okay, because there will be more unknowns in that. Like magnification, as we know, is by FO by 1 by D plus 1 by FE. Okay, and nothing we know. This is only 10 we know. After that, this D is 25 we know, but still it is complicated. Okay, and L also will be F naught plus UE. Correct. So it will be complicated. So with the normal adjustment, we are getting the answer easily in this case. Okay. Fine. So this is microscope and telescope. The questions related to that. Resolution is not in our syllabus, so I am not discussing. So this way, ray optics is over. Finished ray optics. Then we can start wave optics. Little bit, at least some introduction we can have today. So wave optics. Okay. Now in wave optics, we all know that how wave moves. Waves we have studied already. So there is nothing new in that one. The wave is generally represented as, we represent it as A sin kx minus omega t. Okay. What is amplitude? What is wavelength? What is omega? We all know. What is the phase? We know. Okay, so main thing in wave optics, what we have to do? In wave optics, the most important thing that we do is Young's double slit experiment. Young's double slit experiment. Okay, in Young's double slit experiment, what is happening? Interference is happening. Okay, and interference is a process in which energy is conserved. Energy is conserved. Only redistribution of energy takes place. What redistribution? Interference is actually two types, constructive and destructive. Constructive interference and destructive interference. Constructive and destructive interference. In constructive interference, what happens? We are going to get maximum amplitude. If the two waves are interfering, at the point of interference, we are going to get maximum amplitude. And destructive interference is where we are going to get minimum amplitude. Okay. So at this point, amplitude of what? Amplitude of vibration of that particle where both the waves are interfering. Okay. So at this point, amplitude of vibration is maximum. And here, at this point, amplitude of vibration is minimum. Right. In interference, what is the resultant amplitude? We know that. How to measure it? We write it as A equal to root over A1 square plus A2 square plus 2 A1 A2 cos phi. 2 A1 A2 cos phi, where phi is the phase difference. Phase difference between two waves which are reaching at that point. Okay. Phase difference between two waves which are reaching at that point. And in this case, we consider that both the sources are coherent sources. Okay. Sources are coherent. Now, sources are coherent means they have the same frequency. Same frequency sources. Okay. So then what is the meaning of phase difference? Phase difference is only due to path difference. Okay. Phi is due to path difference. That means how much is difference in the path traveled by two waves. So this phi is actually calculated as k delta x, where k is propagation constant and delta x is path difference. How much is the difference in path traveled by two waves? So phi equal to k delta x. Right. So now when we are going to have this phi as, or rather when we are going to have cos phi as maximum, and cos phi will be 0. Okay. For maximum amplitude, what we can have? We can have cos phi equal to 1. That means phi equal to 2 pi n, where n is 0, 1, 2 like that. So if phi equal to 2 pi n, then what will be delta x? Now what is k? K value is 2 pi by lambda, where lambda is wavelength of wave. So if we put it here, this is 2 pi n equal to k, in place of phi, we can write as k delta x equal to 2 pi n. So delta x will come out to be n lambda. So for maximum amplitude, phase difference is 2 pi n and delta x value is n lambda. Okay. For maximum. For minimum cos phi should be -1. For minimum amplitude, okay, you have to take it there. Alright. So for minimum amplitude or destructive interference, cos phi should be minus 1. That means phi should be 2n minus 1 pi. 2n minus 1 pi, n is again 0, 1, 2. Okay, not 0, we take n from 1 here. If you want from 0, you will write it as 2n plus 1 pi. You can write this as 2n minus 1 pi also and 2n plus 1 pi also. That's our wish. Okay. So here n is starting from what? 1, 2, 3 like that. Whereas here n started from 0. There it starts from 1. So when you are going to keep here 1, it will be 2 into 1, that is 2 minus 1, that is pi. So when phi is pi, cos pi is minus 1, we know. That's what we are writing. Okay. So phi equal to 2n minus pi, then delta x equal to 2n minus 1 lambda by 2. Okay. So this is the condition for minimum amplitude, or you can call it as destructive interference. Okay. Same thing we write in terms of intensity also. For intensity, now we know that intensity is proportional to amplitude square. Okay, so same formula in terms of intensity we write as I equal to I1 plus I2 plus 2 root over I1 I2 cos phi. Okay, now for maximum intensity, condition we already have. So for I max, okay, for I max, when I1 is equal to I2, then this will be I plus 2 root over I into I to cos 0. We are taking I1 equal to I2 equal to I. That means intensity of both the sources is same, or amplitude of both sources is same. So I max is coming as 4I. And I minimum will come 0. In maximum questions, we consider or we take intensity of the two sources is same, and that is I. Okay. So one source is there whose intensity is I, another source is there whose intensity is I. Okay. Maximum intensity possible is 4I. If it is I1, I2, then maximum intensity will be what? That also we have to write. No, we will not return. Okay. First we will write this here. So I max. Okay. So here I max is how much? So I max means is this cos phi we are going to write as 1. So I1 plus I2 plus 2 root over I1 I2. That means this is root I1 plus root I2 whole square. So I maximum means is root I1 plus root I2 whole square. Exactly same way I minimum. So for I minimum here will be minus. So it will be I1 plus I2 minus 2 root over I1 I2. That means root I1 minus root I2 whole square. So I maximum is root I1 plus root I2 whole square. I minimum is root I1 minus root I2 whole square. Maximum and minimum. Okay. So based on this itself, if we solve one question. Okay. So what question is there? We have two sources S1 and S2. Intensity of both is I and I. Okay. At any point of interference, we are getting intensity 2I. At any point of interference, we are getting intensity 2I. Now, what is the phase difference between the two? Okay. At any point of interference, intensity obtained is 2I. Intensity obtained is 2I. Find phase difference and path difference of waves reaching at that point. Okay. So here intensity, net intensity is coming 2I. Maximum intensity should have been 4I, minimum intensity should have been 0. But here intensity is 2I. That okay? No problem. So we know that resultant intensity at any point is actually equal to I1 plus I2 plus 2 root over I1 I2 cos phi. Okay, this is the resultant intensity, right? Now then, what we can do? We can put the value, what we know. Okay, so it's given to us that this is I, this is also I, and here also I into I, and this is cos phi. Okay, but resultant intensity is also given to you as 2I only. Okay, now what is here? This is 2I, here also this is 2I, and this is also 2I cos phi. 2I, 2I. This 2I will come over here, it becomes 0. So 0 equal to 2I cos phi. That means cos phi is 0. Cos phi 0 means phi is 90. So we got that phase difference is 90. Now question is, what is path difference? Okay. So phi value we can write as k delta x. So this is 2 pi by lambda delta x, and this is pi by 2. Pi gets cancelled. Delta x value is lambda by 4. Okay. So our answer is pi by 2 and lambda by 4. Exactly same question we can solve if suppose this is 3I. Okay. I am doing it here only. Same question. Okay. Because here I am doing it because we will do directly now. So here S1 source is given, its intensity is I, S2 is there, its intensity is also I. This is S1, this is S2. And at this point, intensity we are getting as 3I. Question is same. We have to find phase difference and we have to find path difference. So what you will do? I resultant. Now I resultant is what you see? 2I plus 2I cos phi. Shall I write directly? 2I into 1 plus cos phi. But what you want should be 3I. So 3I equal to 2I plus 2I cos phi. This comes over here, this is I equal to 2I cos phi. That means cos phi is 1 by 2. Cos phi is 1 by 2 means 60 degrees, phi is 60 degrees. Okay. So phi is 60. We got that one. How much is phase difference? 60 degree means we will be writing pi by 3. Right. So now this we can write as k delta x equal to pi by 3. So k into 2 pi by lambda is equal to pi by 3. Pi gets cancelled. K I have written, delta x is here. Delta x into 2 pi by lambda equal to pi by 3. Pi gets cancelled. Delta x is equal to lambda by 6. Okay. So this way we can calculate the phase difference and path difference if intensity at a particular point is given because of the interference. Again, very commonly asked. Okay. Then what type of question is asked? Then the question will be asked if suppose one source of intensity is I and other one is 4I. Then find ratio of I max to I minimum. Very commonly asked. What do you do? I max, say root I1 plus root I2 whole square. That means root I plus root 4I whole square. Okay. So what we can write over here? Now this means is I can take root I common, no? It's 1 plus root 4. That means 2. It's a square. Correct. So that is What is we are getting? We are getting it as 9I. Okay, there is a 9I. Alright, then I minimum, root I1 minus root I2 whole square. That means root I minus root 4I whole square. Again, same way, take root I common. 1 minus 2, 1 minus 2 minus 1. So minus root I whole square, that means I. So I max to I minimum is 9. I max to I minimum is coming 9. Okay, like this there will be many questions. I max to I minimum ratio, or I max to I minimum will be given, they will be asking you I1 and I2. Okay, that also will do one. Question, I max to I minimum. Let's say it's 16 by 4, not 16 by 4 is to 1 itself we can write, or 16 is to 1 we will write. Okay, find I1 and I2. And okay, fine, that's also easy. Okay, so then what we will do, this is root over I1 plus root over I2 whole square by root over I1 minus root over I2 whole square equal to 16 by 1. That means root I1 plus root I2 by root I1 minus root I2 is equal to 4 is to 1. Okay, and this one here, 1 minute. Find I1 by I2, not find I1 and I2. Okay, so root I1 plus root I2, root I1 minus root I2 is there. What shall we do now? You can do cross multiplication and find ratio. We can do that. So if cross multiplication we are doing root I1 plus root I2, 4 root I1 minus 4 root I2. So bring root I2 is the side, take root I1 that side, so it just becomes 5 root I2 equal to 3 root I1. I1 by I2 we want. So 5 by 3 equal to root I1 by root I2. So I1 by I2 is 25 by 9. I1 by I2 is 25 by 9. Done. Okay. So this way there will be questions based on intensity asked directly. Today we are not doing Young's double slit experiment. That you will see tomorrow. Okay, and tomorrow we will finish wave optics. So today we are finishing here. Okay, ray optics we have finished, and from wave optics also, from where one question at least will be asked, that we have covered. Okay, so just take this, scan this QR code. Here it is. Scan it.